Okay. Let's see. Good. Good. We begin and PC. Perfecto. Okay, we're going to begin. So today we will again continue working on the evaluation and review of the test plan that the STIRP team put together that was the basis for our work in Torino in 1978. And today the first lesson is about the X-ray fluorescence experiments. And I already explained to you the problems that the X-ray machine gave our team and the problems of the X-ray technicians when they were making the X-rays had to wait until the middle of the night when there was no traffic. We all had to leave the room because our walking around on the old 400-year-old wooden floors caused vibrations. So we had to work with some great limitations, but we were able to do so in the end. So the X-ray fluorescence experiments, let me just switch this. The X-ray fluorescence experiments were performed in addition to the standard X-radiographic experiments. This type of analysis can produce quantitative estimates of the elemental content of an unknown sample. So what that means is, using X-ray fluorescence, we could determine what elements might be found on the shroud. One of the things, of course, we were looking for was some form of paint or pigment. And in addition to the X-ray analysis, we also did spectral analysis, which we talked about somewhat already. And that spectral analysis was combined with the X-ray fluorescence. Again, we had with us the spectral characteristics of every paint and pigment used by man from medieval to the modern day. So we had with us a library, if you will, of spectral characteristics for all the different types of paints or pigments that might have been used. And that made it much easier for us to detect them if they were there. And of course, the X-ray fluorescence helped as well, because it could determine which elements, chemical elements, that would be found on the shroud. So it could tell us with a fair degree of certainty which elements from the periodic table are found in the samples we test and in what quantities. So if there was just a microscopic amount, it would tell us that, or if there was a larger amount. And obviously, if there was paint or pigment applied, there would be places where there would be more of it than in other places, and this helped us to determine that. This had value not just for looking for paint and pigment, but also for our overall knowledge of the shroud, and could give us some clues as to what might form the various stains on the cloth and, of course, the image itself. We're going to go back now and look at the test plan again for the X-ray fluorescence. And according to the test plan, the X-ray fluorescence analysis is capable of producing quantitative estimates of the elemental content of an unknown sample, and it works by exciting the characteristic X-rays and measuring their intensities. Fortunately, this is not a course in X-radiography, so there will be no questions on the exam about X-ray fluorescence. In the case of the shroud, the experimental conditions preclude any attempt to make true quantitative judgments. Accordingly, the experimental plan will emphasize the measurement of the experimental precision and the production of qualitative results. I just read that to you. We'll go to the next page. Now, one of the things, I'm going to back up for a moment here. Prior to starting this series of data taking, the equipment needed to be calibrated and the repeatability measured. In other words, before we actually tested the shroud, they tested the system to make sure that it was giving us accurate data. A standard object consisting of certain elements was used and was counted 10 different times so that they could make sure that we were getting a consistent series of results. And from this data, the precision by which the shroud can be positioned will be judged. So before they actually began working on the shroud, they used a test sample that had known elements. They put it and did a test, they removed it and did it again 10 times. And the purpose was to calibrate the instruments and to be certain that we were getting an accurate count of what information might be there. The purpose for including the control areas in the list of priorities that will be shown will be obvious. Each control point will be counted a minimum of 3 times at slightly different points to measure the variability of the object's elemental content over a nominally uniform area. Basically, that means that they took a particular area and took 2 or 3 different tests within that area, but in slightly different places, again, to determine if there was a consistency in the material we were testing on the shroud, or whether it varied in very small areas. One of the places that was important was the blood on the foot, which was counted in the same way as the control point. And this was then compared with the blood on the face and the data taken from the face to see if one of them had been retouched by some unknown artist. So this was a way of comparing the blood samples to make sure that both came back with the same data and one didn't show some paint and pigment where the other did not. And I'm going to go past this. Again, we have the timeline that they figured out in advance. And I still marvel at this to this day, that they were able to compute this. And, you know, these are rigorous scientists that were on this team. And this was, for them, normal operating procedure. For those of us who aren't in the sciences, in the hard sciences, like these scientists were, this may be a bit, you know, overwhelming, but this was normal and typical for the kind of work that these researchers did. Now, the setup involved mounting the collimators, the detector, and the source on a tripod, making all the electrical connections with the sources and the detector. As I mentioned before, we had to be very careful with the instruments because the power in the Royal Palace was different than the instruments were designed for. And so this is why my friend Franco Faya was there, who was the well knowledgeable about the power in the Royal Palace, since he had worked with Professor Ganella during the exhibition. So they knew. So they aligned the X-ray beam, and again, I'm not going to go into too much detail here. Mainly, I'm reviewing this to show you the level of preparation and the care that was taken in doing each of these experiments so that nothing was left to chance. Everything was carefully planned and detailed and performed to the highest scientific standards. And again, I'm going to go through most of this very quickly. I don't want to sit here and read it all to you, especially since you will be getting all of these documents, including this test plan, as that test plan is one PDF file. So you'll get that. I believe there are about 70 pages in this test plan. And so I'm not going to get into all this technical detail right now. Now, this is Roger Morris. He was the coordinator for the X-ray fluorescence group, different than the men who did the X-radiography with, the films. In this case, they were measuring data, but not recording it onto films like the X-radiography guys did. So we had a number of X-ray experts on our team from different phases of X-radiography. Now, I'm laughing already. Apparently, I stayed in that room 102 hours out of 120 hours. But there was a point where not only did I need to get some sleep, I needed to take a shower. And so I had to leave. And it was very frustrating for me because as the only documenting photographer, if I wasn't there, things were not being documented. So I must have been asleep when they did the X-ray fluorescence because I could find no photographs of the experiment in my extensive collection. So and as I just said, I spent 102 of the 120 hours in the room. So it frustrated me when I was putting this lecture together because I could only find one image that even showed the instrument, and it's in the background and not in use. It was just standing in the background behind one of the other experiments that was going on. Fortunately, I contacted Joseph Aceta, and who performed the experiment, and he kindly sent me the only snapshot that he made of this particular test. Now there's that instrument in the background. That's the instrument in question. And as you can see, Sam Pellicore is using the wild photo microscope to examine an area on the cloth. But this is the device that they used. And as you'll see, oh, there it is. Okay, I forgot I had little pointers. I always forget that. Now, this is the snapshot that Joe Aceta took, but you can see Roger Morris and you can see the instrument here during the use while it was being tested. And again, they have to remove the steel panels from the examination table for the X-ray fluorescence as well. You just don't want a big hunk of metal when you're doing the X-rays. Now, from the X-radiographic data, there were something like 5 or 6 papers published. You will get all of these papers. I don't expect when you get them and you read them that you will necessarily understand them. I certainly don't understand all of these. And of course, that's not my field of expertise. But all of these papers will be in it, or after October 8th of this year, all of these papers will be on shroud.com as well. And the one we're going to look at in a little closer is the X-ray fluorescence investigation by Roger Morris. And this is the actual paper that was published in the journal X-ray Spectrometry. You all read that? No. And let's see what I've done here. And you can see through the paper that they indicated not only the technological setup of the equipment, as you can see in the diagram, and an explanation of how that works, but you can also see, again, some shroud photographs indicating areas of interest that were inspected using this particular technology. Now, I'm not quite sure myself what the little circles there are, and perhaps by reading it in more detail, we can understand that, but we're not going to worry about that. 1 to 7, so that, remember I just read that section about in a similar area, they would move it just a little bit. That is obviously an indication of one of those areas where they tested different areas within a small range, because this is a close-up section of the cloth. So again, the purpose of the course isn't to teach you all of the scientific techniques that were used by the STIRP team, but to overview them, to give you an example of what typically these men were doing and the different kinds of tests that were applied. Now, I can't speak to the X-ray technology of the 21st century, but if we look at the imaging technology comparatively from 1978 till now, we know the dramatic advances in the imaging technology. We can assume, I think, reasonably that the same types of advances have been found in the X-ray technology, or for that matter, in the spectral technology. Now, instead of a big giant spectral instrument like we used in 78, there are now handheld spectral instruments far more sensitive than what we used in 1978. And they're much smaller, more compact. Remember, this is in an era before solid state electronics, which means all these machines were big with circuit boards inside with individually soldered components on the circuit boards. So the just the precision of the technology has changed dramatically. And this is why I believe so many of us who've been involved for so many years with the shroud would love to see the newest technology applied. I think many of the questions that our team raised with the data we collected could better be amplified and evaluated, and with much more precision, if another set of tests were permitted at some point in the future, allowing us to apply this newer and more sensitive and more accurate technology. And again, you can see they carefully noted the areas that they tested and documented that. And of course, part of science is documentation. And that's so that it can be properly published into peer-reviewed journals such as this one. And the reason for that really is the whole concept of peer review of publishing is so that other researchers who might feel that they have knowledge in this area might attempt to repeat the experiments done. Repeatability is essential to the scientific method, which is why we publish not only our conclusions, but our data and our methodology, so that future researchers can try to repeat the experiments, obviously with newer technology now, but at the same time allowing for credibility to be given to the conclusions made. Repeatability is the secret of success in science. And here you can see they've published graphs and charts with all of the different numbers. Again, not anything that we're going to worry about in this course, but definitely indicating a level of scientific research that is at the highest standards. Even 40 years later, I've spoken to scientists who've read these papers that are within the field, and they say that what STIRP did was as good as could have been done in 1978. And of course, you've now seen the limitations we had in the Royal Palace. So it's even amazing at times that we were able to accomplish as much as we did in such a very short period of time. 5 days sounds like a lot of time, but when you have 25 different kinds of tests that you want to do, 5 days becomes a very narrow window of opportunity. And again, you'll be able to look at this and review it on your own once we get you all the materials. But let's see if I did a close-up. So let's see what the conclusions are. We might read some of this. We've presented the results of a series of X-ray fluorescence measurements on the Shroud of Turin. There appears to be no evidence of heavy element concentration differences between the image or non-blood areas and the off-image points which, had that been there, would suggest some kind of forgery. The data indicate generally uniform distributions of calcium and strontium over the investigated areas of the cloth. We suggest these quite possibly represent airborne dust deposits, because for many years, the shroud was displayed publicly. It was actually hung from balconies so that any airborne dust, debris, or even pollens could be deposited onto the cloth coincidentally, just because they're floating around in the air. So these are things that they look for. And what this is really telling us is they didn't find any evidence of any paints, pigments, or dyes that might have been used to create the image. Substantially non-uniform concentrations of iron were observed, particularly at the dorsal foot and side wound blood stains. What a surprise. They found iron in the blood, which of course there is iron in our blood. So this is, at least in part, corroboration that the bloodstains are most likely blood. Now, of course, we'll talk about this, I think, in a later lecture, but chemical analysis of the blood found hemoglobin, porphyrins, serum albumin, all components of blood. So this, coupled with the other data, gives us a very strong, allows us to make a conclusion that this is most likely real blood. In view of the difficulties that were encountered, and despite the conclusions reached thus far, we feel that this work can only represent a preliminary investigation of the problem. Even these scientists realized that we could not make absolute statements based on the data collected. And that's an indication of good science. You don't jump to conclusions or extrapolate a small amount of data to draw massive conclusions. Recently, Giulio Fanti, who we will talk about in one of the later lectures, I guess next week, obtained a sample from one of Ray Rogers' tape samples off the shroud and found one particle of pigment, just a microscopic particle of pigment from an area of a bloodstain. Giulio extrapolated that all of the bloodstains on the shroud must have been painted over. Now, again, I don't mean this in any way to demean Giulio Fanti, who's an avid researcher and prolific in doing lots of work at the University of Padua. But Giulio's an engineer. He is not a hardcore scientist. Scientists are obligated to follow the scientific method, which is very limiting and restrictive. Engineers, by definition, are trained to think outside the box and to sort of break the rules to come up with new engineering concepts and solutions. So it's understandable that he might, in his excitement of doing this work, because he certainly has a great passion for it, that he would take a very minute amount of data and extrapolate that into something beyond what the data can actually support. So again, and Giulio's not the only one who's done this. I'm just using him as an example because this happened very recently, and from a sample that our organization made available to him. So I will talk about this specifically in one of the later lectures, but not in this half of the course, in the post-STIRP era course, which are the second 12 lectures I'll be giving. So on the basis of the work that they did, we offer the following points which might be considered in any future X-ray fluorescence investigation. So basically, they carved a new path, if you will, and said, okay, we've achieved these preliminary results, but future research should be done to carry the work forward and do it in more depth than we were able to do in the short period of time that we had. And you can see that there are a number of references they used, remembering again that since no real science, in-depth science, had ever been done on the shroud beforehand, we could not consult previous research on the shroud to use that as a basis for what we did. We were the pioneers. And sadly, since then, no other in-depth testing has ever been permitted. And so you can see that there were great limitations in the work that Stirp did. And you can see that the scientists themselves acknowledged that. And that's an indication of really good science, that they're not leaping beyond what the data can support. But all of the preliminary data did show that there's no paint or pigment applied, and that the blood has, that the X-ray fluorescence of the blood samples showed a high content of iron, which one would expect from blood. So again, all of the data combined is what you need before you can draw an in-depth conclusion. And I think in this case, these men were wise enough not to go over that line and to say, oh, look, we proved something. I think I might have already mentioned to you that occasionally when I would write the word proved or proven into something I published on shroud.com, I would immediately get a phone call from Ray Rogers yelling at me, we don't have enough data to say that. But Ray taught me to be empirical, to stick to what the data shows. And he used to say the same, as Al Adler said the same thing, we have to follow the data. And that's what good science does. So maybe the most important part in reviewing some of these highly technical experiments is just to demonstrate to you how careful and cautious these men were not to overstep the boundaries of the data they had collected and to draw conclusions that could be supported by that data itself. And let's see, we have, I'm not sure if I've highlighted anything there. Okay, so we have basically their references, and I think, let me think, this last one, this experiment was performed on the shroud without having the backing cloth removed. And this is important. Some ambiguity is therefore inherent in the interpretation of the results because the backing cloth, or the Holland cloth, that had been sewn on in 1534 by the Poor Clare sisters to repair the shroud from the Chambray fire of 1532. That backing cloth was there, and obviously, based on what they're saying here, that would have some potential influence on their results. So they carefully noted that. We feel that this problem is minimized to some extent by our general survey approach to detect the Heisey element differences among blood stain, image, and background. So even though these are not definitive results, they do show the differential between the different types of area on the shroud that were tested. And again, this allows them to draw some conclusions, but nothing that was definitive. Nevertheless, in any subsequent study, this problem should be avoided, meaning if they do this again, it would be good to have the backing cloth removed, even if just from certain areas for a period of time, before any definite conclusions are reached from measured trace element distributions. So again, more important than anything else is to show you that they didn't get a little bit of data and immediately say, oh, the shroud's real. None of us said that. Nobody said that, because our data doesn't, one piece of data cannot support that conclusion. People have asked me, well, why are you so convinced it's authentic? What one thing was it that convinced you? And really, it was not one thing, but an accumulation of all of the above. It took me 17 years because I had a lot of questions. I'm not a scientist. I didn't always understand all of the details of what these scientists were doing. And because of that, I was very slow to come around to this conclusion that it was authentic. And it was the accumulation over that 17 years of all of our data and other data that was done by other researchers that eventually brought me to accept that the Shroud of Turin was authentic. So again, science has to proceed very carefully. And when you're dealing with something as controversial and emotional as the Shroud of Turin, you can't jump to any conclusions because millions of people are looking at this as an object of faith. And the last thing we wanted to do was cause any harm or give false hope, if you will, to those folks. We had to stay within the confines of the natural sciences. So we could not do much speculating, but I think it's this comprehensive collection of data over all of these experiments and the study of that over all these years that became the kind of final thing for me to convince me this had to be the real thing. And with that in mind, we have come to the end of this lecture. Thank goodness, because this is one of the most technical ones and one of the most difficult ones for me to deal with, because this is so far from my field of expertise. So again, we have a few minutes before we take a break. So again, I'm happy to answer any questions or take any comments if you have them. Anybody have anything? Yes, sir.
I have a very naive one.
Okay.
Why did they let you out only for 5 days? You ask maybe to a couple more days.
Well, the question is, why did they allow us to study the Shroud for only 5 days and not give us more time, an extended period of time? Well, you know, I was sort of at the bottom of the team. I was not one of the team leaders that negotiated with King Umberto or with the custodians in Turin. And to be honest with you, we weren't sure we were going to get even 5 days. So we had an alternate test plan, 24 hours, where only certain of the many experiments we ultimately performed were going to be used or applied. I would like to think that they would have given us more time, but we were so amazed when King Umberto said yes. And I think I reminded you at the beginning of all this that the Turin authorities were not thrilled at this idea of anyone, but especially maybe a group of Americans coming. And so the fact that we ultimately were given the full amount of time, which was technically for our project 96 hours, because there was another 12 hours given for the first 12 hours to the Italian researchers. So 120 hours was the total. We were very fortunate to be able to fulfill the complete test plan that we did in that 5 days. And I think maybe, I don't know if that was an arbitrary time period set by the Turin authorities or King Umberto. I don't know. I was not high enough in the team to know that information. But I think what's most important was that we were given the opportunity for the first time in history to examine the Shroud. And although the 5 days and nights that we had was very limiting, it's still the best we have. And so I don't know if it was a political consideration, or remember, the Shroud had already been on public display for about 6 weeks. And so they removed it from display and gave us that 5-day period for all of the examinations from both the Italian researchers and the American team. So maybe they thought that was enough, because our test plan was based on that 5-day period. So my guess would be that that was what we were told we were going to have at the most. And so I think that it would have been nice to have even a few more days. But remember also that a few experiments sort of came up during the actual testing of the shroud. And so there were a few slots that were left open for anything, the miscellaneous things, and I mentioned in one of yesterday's lectures. So I think that perhaps we would never have gotten to make the transmitted light images, obviously, if we were limited to the 24 hours, which was our backup plan. So we were fortunate enough to complete all of the things that we had intended to the best of our ability. And we're able to add a few additional things sort of during the event to help us further get new data. And as I explained, some of these things could not have been anticipated. In other words, we couldn't, as well as these men did in anticipating almost everything, there were some things that could not be anticipated. The best example that I can give are those transmitted light images with light passing through the cloth, which was basically by accident when Professor Rigi turned on the focusing lamp of his endoscopic camera system, and we saw the effect of transmitting light through the shroud. That's when they said to me, we'll give you a half hour to do some transmitted light of the entire shroud. And those I still to this day believe are the most important images that I made in 1978. They have true scientific value, where the others were more from a documentary phase, showing the men at work, showing the preparation and things of that nature. So, but yeah, it would have been nice to have a week or 2 weeks. And, you know, in the real world of science, if you have an archaeological object that you're studying, you can study it for years. The shroud is a little different, though. And I think after a 6-week public exhibition, one of the longest in its history at that moment in time, the fact that we were given that 5 days, I will forever be grateful for the 5 days. But I'm sure that every member of that team would have said the same thing. Well, if we had another 5 days, we could do this much more. And so we're all hopeful that at some point in the future, hopefully, while I'm still alive, I would love to see another series of tests that could carry the work that we began further, answer some of those unanswered questions, and perhaps make some new discoveries using more refined and sensitive technology that is available today to maybe further our knowledge of the shroud. Why don't we write to Pope Francis? He is, and I will share this publicly, obviously. My board of directors, STERA, Shroud of Turin Education and Research Association, recently at our last board meeting made that recommendation. One of our board members said, we need to write a letter to the Pope. Well, I disagreed, and here's why. If you go back to the radiocarbon dating in 1988, Dr. Harry Gove, who was the inventor of the AMS radiocarbon dating method used on the shroud, when they were planning the radiocarbon dating, initially they planned to have 7 laboratories participate. And then sort of after all the protocols and everything had been completed, they decided only 3 laboratories would participate. And Harry Gove's laboratory was not one of them. So he wrote an open letter to the Pope, which was published in La Stampa. Big mistake. Immediately became persona non grata. This is not the best way to talk to the Pope. And we found that out from that example. Since then, there have been several attempts at petitions that were circulated on the internet for people to sign a letter to the Pope asking him to allow more tests. These were completely ignored by the Vatican. It had no effect. So I had to calm my board member down, and I'm going to be discussing future testing with some members of the Turin Centro, Paolo De Lazzaro, who is a physicist from ENEA at the laser laboratory there. I'll be having dinner with Paolo sometime this week. And he is now the vice president of the Turin Centro. And he is not only my friend, but someone in authority on this, on the International Center for the Study of Syndenology. And I'm going to discuss this with Paolo. My feeling is it would be better if one individual small group, and especially not an American group, be the leader of this. It should come from Turin. And so my feeling is what would be an ideal approach would be for the authorities of Turin, who have the highest credibility, I believe, in the eyes of the Pope, to be the leader of such a request. And I think that all of the international organizations around the world, in Spain, in Portugal, in England, in America, would all be willing to sign as signatories supporting what the Turin Centro might propose. I think from a political point of view, that's probably a much better approach, and to go through the proper formal channels to present this to the Pope in the appropriate manner, but not just sending him a letter, which he would probably never see anyway. So I think that we're all hopeful that this might be a viable, possible solution. But again, I'm just one little guy from the United States that has no authority and no word other than, the work that I've done over the years. And so I think that this is an approach that might be a credible approach, but going with a petition or a letter directly to the Pope or publishing it in the media would not be a good idea, because previous people who did this wound up in big problems. So Harry Gove did not get to participate in the radiocarbon dating other than as an observer with the Arizona laboratory. They were kind enough to invite Harry Gove to come and sort of observe as they did their work. So one has to be very careful. And remember, we're dealing with an international issue, and I don't think it's appropriate for an American group to start kind of trying to take the leadership role in this. I believe that has to come from Turin. And I think we can take a break.